Okay, this is problem 7 on the homework, and this is a problem that gives a lot of people issues. It's part B, finding the velocity at specific times. Now this is a position time graph. It tells you the position of an object at various times. When you want to find velocity, the velocity is the slope of an xt graph. So we got to find the slope, and we want the slopes at these specific times: 1 second, 9 seconds, and 16.5 seconds. Now it also asks for speed, so that is number only. No direction. It's always positive. It has a unit, so when I say number only, I mean no sign. Doesn't have a plus or a negative. Now for V1 at T1, 1 second. So here's 1 second. Follow it up here. It's right there. Now that's really hard to tell what number that is there, but the speed or the velocity is found from the slope of the graph. Now, speed or velocity, the magnitude of velocity, is the slope of this. And since this is a straight line segment, we can find the slope of the whole segment, and that will be the speed at every instant along that line. If it was curved, it would be a little more challenging, but this is straight. Now, when we have straight line segments, taking the biggest segment is the biggest distance along that segment is best. And it's also hard to know what number that is right there. But I know here is 0, 0. That's 0, 0. And this, I know, is 7 and 3. It's 3, 7. 3, 7. And that slope equals the change in y over the change in x, which in this case actually is change in position, x, over change in t, time. And that change, it goes from 0 up to 7, is a 7, and it goes from 0 over to 3 over 3. So that's 2.333 repetan, and that's in meters over seconds. Now at 9 seconds, I go to 9 seconds, I go up here, that's on there. And that's kind of tough to tell what number that is exactly at 9 seconds. It's not quite 9 meters per second, meters. So I need the slope of that segment. Since it's part of another straight line segment, I can just choose this point, which is the point 6, 7, and this ending point, which is 11, 10. And that slope right there is the change in the vertical axis, y, over the change in x, which in this case is the change in x over change in t. That gives people trouble. Vertical over horizontal, rise over run. Our vertical is actually an x measurement. Our horizontal is a t. So I've got 11 minus 6, 11 minus 6 over 10 minus 7, 10 minus 7. And did I do that right? No, I did x over y. So that's a common mistake. I did x over y. I haven't wrote them down right. It's y over x. 10 minus 7 over 11 minus 6. Caught myself. And 10 minus 7 is 3. 11 minus 6 is 5, right? So 3 over 5. And 3 over 5, if you divide that out, I think the problem asks for 2 significant digits. Yeah, 3 divided by 5 is 0.6, so 0.60, right? And it's a positive, but that doesn't matter. 0.60 meters per second. Then it asks for 16.5 seconds. That's right here. That's like there. It's hard to get that exact number there. But again, the speed is going to come from the slope of this, And that's one big straight line, so I can do the whole thing. And this first place has an x of 16 and a y of 7. And this has an x of 17 and a y of 0. So its slope changing the y-axis over the change in the x-axis, and the y's, it says 0 minus 7, and the x's is a 17 minus 16, and that gives us negative 7 over 1, which is negative 7, right? Is that right? Did I do that right? I feel like I didn't do that right. No, that's pretty steep. But the negative doesn't matter, so the speed is 7 meters per second. All right, so that's how you do that. Remember, do the whole line segment, beginning to end, because you can clearly see what those values are. Doing intermediate points is difficult. It's difficult in that. All right, I hope that helps. Good luck on the rest of the homework.